my background is not marine engineering, so it was very interesting to see the last presentation, but I'm not going to be into the detail like that. Fluid dynamics is where my main interests have been. And actually, why now am I talking about future fuels? Well, actually, we started to look at the whole ship and how it was operating, to look at where we could make efficiency savings, and that sort of led us into thinking about fuels. And hopefully, some of our work we'll share in the presentation. But I really am looking to the future here, and it's maybe a world which doesn't necessarily involve diesel as a fuel, or in fact engines as the main source of energy. So maybe not such a good message to be trying to talk out today to some of the audience. But hopefully I think we'll sort of see that this is kind of going to be a journey where I think many of the technologies will come into play. So, but I say a decade ago, in fact just over a decade ago, I took over supervision of a PhD student, Ivo. Some of you may know him, and he was really fascinated about the idea of using hydrogen as a fuel. And he was looking at how you could move, obviously hydrogen was very expensive as a fuel, so you want to look at moving high value goods, perhaps more environmentally friendly than moving them on aircraft. And could you go fast enough to be able to do it, and would it be economic? I suspect the answer was it wasn't economic and still wouldn't be economic, but it was certainly an interesting part of the concept of a vessel. And he had this sort of catamaran with some hydrofoils on, so he was really thinking into the future. But that sort of, to some extent, was one of the triggers for our interest in this. So the layout of my talk is a little bit of a mix of the future fuels and the maritime environment agenda around that, future ship powering and how we do that, and then how we manage these more complex energy systems that we will have as a result of that process, I suspect. So we're all aware of what our challenge is in the maritime industry. We've got the global challenge of greenhouse gases, and the fact that at the moment we're contributing fairly significantly as an industry. We know that, or we expect that the population is going to rise, and from 7 billion, just over 7 billion now, to will it peak at 10 billion or higher? We don't know. It's very difficult to predict these things, but we certainly know that it's going to be increasing. We know also that the wealth of everyone in the world is going up. It may not be going up equitably, but it is going up, and as it goes up, that typically generates more trade. And DNV GL predicted a 32% rise in trade between 2016 and 2030. I missed a zero off, sorry about that. So that's the kind of agenda on the global greenhouse gas side. Now if we look at the local environmental challenge, and I've put up a Port of Southampton map with a few little bits pointing out where ships come and go. And we know, Moto gave a very good explanation of all the types of emissions that influence air quality, and we know that those emissions have quite a significant impact on populations that are exposed to them. If we look at, and The Guardian did an article going on about dirty ships. Diesels are ships of the worst offenders, so you may disagree with their slant on these things, but they looked at some fairly robust measurements of how much shipping is contributing to global NOx and SOx, and that 70% of our emissions are within 400 kilometres of land. Whether that's a relevant dimension, I'm not sure, but it certainly sounds like there's a lot of emissions going not too far away from where people live. So if we look at Public Health Southampton, has looked at the prevalence of a variety of emissions within the, they've looked at the occurrence of various medical conditions within the city of Southampton. And you have to ask the question is, some of those will be related to air quality issues within the city, and where are those coming from within the city? And the sort of highlights of some of those areas may be some concern when we think about southwesterly winds from what's happening in the port and the other activities. So we had a recent student project, Cameron Owens, who took, and this is an example of sort of big data being one more of the things that we see as a technology that can really help us. And he took AIS data for 1 month in October 2016 of all the Southampton water movements of vessels of all different sizes and activities. And you analyze that data and said, well, if this ship, can we identify from the data if a ship is stationary, so maybe it's on hotel load, if it's doing maneuvering, or if it's at sort of standard speed. And you can look at the operation for a given size and category of ship and estimate what the emissions would likely to be. Once you've got that model, and you can say, well, I can then change the fuel type, and I could say, well, what would happen if we moved to a world where everything was fueled by LNG, or we took the sort of cold ironing approach and we connected the ships when they were docked. And as I said, it's a student project, so we're not talking here as robust as you would want for a sort of full journal publication. But it's interesting. You can do things with the AIS data. You can say, okay, where the ships are going backwards and forwards along this. Sorry, I can't point to it. You can see where the majority of ship movements are within the port, and this is estimating where the CO2 emissions were coming from over a period of time. And you can see, well, these are effectively then sources of emission, whether in this case it's CO2, but equally NOx or SOx. And his preliminary calculations, if we change to LNG as the fuel instead of a heavy fuel oil, then 38% reduction in CO2, 87% reduction in NOx, 93.7% reduction in particulate matter. These are big reductions, so this would be a very effective way of controlling the emissions from the shipping sector within Southampton water. But that presupposes that you can make an instant change in fuel type, which, as we know, is not something that's going to happen overnight. So one of the places I started with sort of my interests in ship powering was I was involved in Royal Academy of Engineering, put a report together. Doesn't seem that long ago, but apparently it's now 5 years ago. Originally it was driven by the desire to think about the use of small modular reactors as potential sources of power on board ships. But actually it broadened its context to actually look at all the future ship powering options. So it's an online report. It's a really good read. I'd heartily recommend it. I know it's 5 years since it was created, but rereading it yesterday, it's still pretty on the nail, I think. It examined all the different types of future fuels that we might be thinking about, presupposing that we're not going to be using the sort of heavy diesel fuels, heavy fuel oils and things for much longer. So it looked at nuclear, LNG, batteries, fuel cells, methanol, hydrogen as all potential methods of powering ships. My take from it at the time, and still is, that effectively the direction of travel, if you're looking for clean shipping, sort of emission-free, is going towards a world where we would use fuel cells with hydrogen as a potential solution. Now, there's a lot of steps, and I'm going to look at a few of those between where we are now and where that, if we go along that journey, how we would take those steps. So, and this I think was quite an interesting, I'm not quite sure how visible it will be from the back, I'm afraid, because I just took the diagram, but effectively looked at the 3 different sort of reciprocating engine technologies, other propulsion technologies, so gas turbines have included hybrid systems in here as well, and then hydrodynamic achievements, and when are things going to be happening, and sort of short term, the diesel engine is going to be a sort of a workhorse for quite a long time to come. We're going to start putting, as the last speaker so eloquently talked about, SCR systems are now going to be sort of in operation. So that short-term phase is now sort of underway. And looking at other types of fuels that we could burn in existing engine technologies, from LNG, which is obvious, as just gone through, isn't it? A sort of relatively straightforward way of reducing CO2 and then the other emissions. and then potentially going to a world where we're using something like hydrogen, probably as a mix with some other fuel inside a standard engine, or a modified version of a standard engine. And then we go more radical, and we're looking at worlds where we're probably talking about all electric ships. And so then hybrid systems come in, sort of mixing up the energy, and potentially looking at battery-only powered ships. And there are already some examples there of smaller vessels which are just using batteries to provide a very clean way, a locally clean way of powering the ship. And I'm not really going to talk about the hydrodynamic enhancements today, because that can only ever take us so far. The key bit, and why I put the data up here on, if we look at gas and liquid, it seems to have chopped off the liquid bit, but the key bit here is the energy we can get out of a fuel. So 33 kilowatt hours per kilogram of hydrogen, compared to the sort of 11 or 12 diesel. So well, it's nearly 3 times as effective per kilogram. But actually what matters is the volume that you need to store it. And it has a very low density as a gas, hydrogen. It has a higher density when stored as a liquid, but you need to do that at a very cold temperature. So, and if you want to store the gas at a high pressure as well, you can reduce its volume. So you end up probably with 3, 4, 5, 6 plus times the volume required to store a given amount of energy, which is what you'll need for your, that's not going to change how much energy you need to move your ship around. So you're now thinking about a larger volume required for your fuel system. And as we know, when you compare the kind of the combustibility of something like in hydrogen in comparison to heavy fuel oil, we have a very different regime there as to the safety aspects that need to be considered. So I know there's some work led out of University College London where we've looked at how we decarbonise shipping, how we go from where we are at the moment, where we got 2-3% of the world's CO2 is coming out from shipping, so to a world where if shipping expands at the rate it is expected to do, and it doesn't do anything, but the rest of the technologies around how we use energy decarbonise, then shipping will become ever more a bad boy with regard to its contribution to the climate. So there's a real pressure, and IMO is pushing on that, which I'm very pleased to see. But we have ships that last 20, 30, 40 years. So if we're going to have a ship which we are operating now, can we retrofit technology which will give it less of an impact in the immediate, before the time the fleet has renewed itself? However, retrofit, it's much harder to change our energy use. It's typically limited to ship types, and some of the smaller that you might want to feel it's economic to do this. And typically you're probably going to add mass, but for some of these systems it will start to build demand, and that's where the kind of demonstration projects which are being funded really always help stimulate the market to think, well, actually it is possible to do it. Somebody has gone through the safety and regulatory hoops to make it work. What can we learn, and how can scale up from that? And I think it's a really challenging time if you're going to be looking to sort of build a new vessel in the next few years, because you can probably expect that the energy technologies will change significantly during its lifetime. So how do you deal with that in your design? So you want it to be kind of future-proof as much as you can. So that's why people are looking at modular power systems. Can we think about designing ships which have effectively a space where you can drop in different types of energy technology as the future evolves in front of you? And that's, again, so containers become one of the things you can think about. Can we have containerized systems for fuel storage and for the actual different types of energy generators that allow you to say, oh, it's okay, for the next 10 years we can do this. 10 years' time we can take those modules out and we can put these ones in and keep going. So what are the solutions? And hopefully some of these are starting to sort of come into fruition. we started looking at hybrid systems probably about, again, 8 or 10 years ago, and to some extent we were mocked for doing this. They said, that's never going to happen in shipping. It's not something that's possible. It's too expensive. If we look now, the last 2 or 3 years, and how many people are talking about hybrid systems, it's going up every year significantly, because actually we're starting to get a tipping point, especially with auxiliary power. You know, the battery technologies that we can purchase have come down in their price. The volume of production is starting to increase significantly, so suddenly there is a real opportunity to do that. And when people look, you know, the EEDI, if you can actually use a hybrid system where you've got that power boost from your batteries to deal with emergency situations rather than installing a larger engine, it becomes even more, it becomes again a cost-effective thing to think about doing. Even now, at the sort of smaller end of the vessel market, there are people looking at sort of complete main power systems which go all electric, and that moves us to a world where we're looking at fuel cells rather than using some kind of more conventional fueled system. But yeah, that's a few vessels at the moment, as I say, demonstrators and ones that will sort of explore the opportunities. In the immediate, as that kind of report went back, we can clean up by having dual fuels, burning a clean fuel in the ECA area and something that's not so clean outside of it. But those things are being forced through, and we'll be moving to a world where we have a sort of cleaner fuel to start with, or at least where it's emitting, as it were, as opposed to where it's being cleaned up. I think, and I think again, it's difficult to say at the moment. Fuel cells certainly has an appeal to it, and I'll explain a little bit more about that in a minute. But you know, if we can look at cleaning by mixing hydrogen with fuel oil or LNG, we can get quite a reduction in the CO2, because a lot of the energy is now coming from the hydrogen combustion, not from the carbon-based fuel. Can engines be re-engineered to take hydrogen as a proportion of their fuel? The answer is yes. People have done it, and done it on large engines as well as small engines, and percentages that go up to sort of 20–30% coming from hydrogen. So it's a technology that is relatively easy to do. What you've then got to think about is how you actually manage your hydrogen fuel on board your vessel, and do that if you're looking at a retrofit solution. That could be quite a challenge, and all the regulatory processes that sit around that. I know there are companies already looking at that design space. I know there's aware of one in Holland that's actively pursuing that as a potential solution for retrofit. So again, I think a bit like with the hybrid use of energy storage on board vessels, I think it may be something that happens more quickly than people anticipated, or at least the first solutions. Fuel cells, for those who are not aware, is with direct conversion of an electrochemical process into a reaction into electrical energy. It looks kind of like a battery in reverse. We kind of allow oxygen and hydrogen, if we're using that as a fuel for the fuel cell, to sort of permeate, and between the anode and the cathode, we create a reaction around it, and that reaction creates an electrical output or load, and then we apply that to a load, and hence we can use the electrical power to move our ship. There's two types of technologies, and primarily there's proton exchange and solid oxide fuel cells. They all are like little batteries all put together. So you take many cells which develop a small potential, you put lots of them together, and you suddenly have a stack that can create a significant amount of power. Like batteries, they're restricted in how many cycles they can operate for, and so there's a problem possibly with restricted life and then costs associated with replacing them. There's also a problem that they don't respond very quickly to a demand. So if a demand comes up, you can't sit there and it's going to be a while before it reaches the amount of power that you're trying to demand. So that's a problem about how we manage manage the fuel cell. It's interesting. The last 5 years, fuel cell systems, they're scaling up the technologies. There's systems now where they're looking at, I just picked off one, there's one company, PowerCell in Sweden, they're developing a 3 megawatt system for a 40-foot container. And this is like a complete system. So we're starting to get to the scales which look feasible. As I picked up 2 or 3 companies there, all of whom are sort of actively in this market and looking at sort of large systems. You can look at putting some of them shoreside, so you have a clean source of energy for mooring up ships. Your infrastructure is there with a container. So the challenge with the fuel cell, and this is one of our pieces of work that we've done over the last few years, is looking at the energy management and how you actually account for, how do you design a system which has got the right amount of fuel cell, and actually because of the charge up time you need a battery as well. So it's a hybrid system, you need a fuel cell and you need batteries. How do you size the relative components? How do you understand whether you can satisfy all the sort of safety requirements as to how much power the ship has in hand, how robust and redundant are those systems. We use publicly available data from a vessel which had been operated and sort of stored all the data for its operation. And the PhD student created a sort of MATLAB Simulink model which allowed us to sort of navigate the ship on its voyage there and back, show that our energy demand met what had been measured, and then we say, right, now we've got a system where we can put in different fuel systems, as it were, and see how we size it to make it work properly. So this is, if people are interested, the data's out there. It's Smyril, I don't know how to pronounce that really. 123 meters, the vessel for the Faroe Islands. So it's a reasonable scale of vessel. But I say the good thing is that the energy demand is there. So it's now, can we design a system which supplies that energy? And we did a comparison between a conventional diesel system and then a mix of fuel cell and battery, and managed together with the electric motor drives. At that stage, we were looking at the NEDSTAC fuel cell. So rated power per module is about 50 to 72 kilowatts. And you stack a number of these together. You put a lithium-ion battery in as your storage. And again, the costs here are quite large for the battery at that stage and the NEDSTAC. And that was probably 3-4 years ago now. So his costs will probably have come down. And we needed a lot of fuel cells, and we needed some fairly chunky batteries as well to make the whole thing work. And we could look at sort of comparisons of metrics, sort of like the weights and the volumes and costs. And okay, we look a hybrid system here where cost is way higher than the existing system. But you have a green system, it's got no emissions. So, if we're moving in a world where we're looking to have zero emissions, there will be a cost associated with that. But there's also, effectively, in the cost embedded here is the fact that there's a very small supply of hydrogen at the moment, so relatively it's very expensive. Potentially those costs can come down. Similarly, the lithium-ion batteries and the fuel cells in particular, if we see commodity products like cars driving their mass production and their costs are coming down, that technology then becomes much more cost effective for the maritime industry to consider. So Moto and I are part of an International Energy Agency hydrogen implementing agreement, Task 39. So it's a good classic international collaboration of people from around the world looking at hydrogen in the maritime. It's got a 3-year existence, so its final reports will be coming out next in 2020. And it's interesting, we've had 4 meetings so far. The 5th one is in Southampton in March next year, so hopefully I'll kind of send some information around that if people are interested in it. We had a few open sessions at the last 2-day meeting in Trieste. Seeing the companies and organizations presenting the developments in hydrogen and fuel cells around the world is really quite exciting. There's a lot of things going on, and actually a lot of the technology challenges which we could envisage are actually being actively addressed. I guess from my perspective in the UK, I think this is an area we need to be pushing at as well, because I think technology-wise, many of the solutions we find there will have a worldwide marketplace for. So, just some remembering of some of the challenges we face with hydrogen as a fuel. Its safe operation, storage and pressure at low temperature, and its volume, those trade-offs. And actually we start looking at refueling a ship in a similar time that we have at the moment. That's a lot of hydrogen we have to move from a bunker vessel or shoreside on board a large vessel. So that poses some challenges. People never really had to deal with hydrogen at those kinds of flow rates. The supply cost is probably one of the big problems at the moment, because there isn't a large market for hydrogen as a fuel. It means it's very expensive. But as a way of generating hydrogen, it is it is possible that hydrogen generation from renewable energy in particular becomes a viable process, as quite a lot of our renewable energy electricity generation costs come down as well. We can, in the intermediate, use other fuels for fuel cells other than hydrogen. Some of those result in local emissions, and some of those still result in carbon dioxide as a product. So they're not necessarily an ideal solution, but they may provide an intermediate step to where possibly we're going. For those of you, again, who are interested to see what some of the things happening in the US, the California Hydrogen Business Council is really trying to tackle the challenge of the ports in Los Angeles and Long Beach. They have a big emissions problem there, much larger scale than Southampton has as a city. Many of the poor parts of the city sit in the sort of likely emissions path once it's been generated. So there's a lot of stringent regulations, as we've heard, coming in for operations both in the waters and at port, and the need to sort of connect into the local grid and things. But now some of the projects they're looking at actually zero emissions for the lorries taking the containers to and from the port. They see that being one of the key parts, because they're even worse than the vessels, as it were, for local emissions. Then they have to create hydrogen fueling stations. Then they have to create a biogas to hydrogen plant to create the hydrogen that they're going to use for all these vehicles. They're also looking at a fuel cell powered top loader for lifting, putting the containers. But one of the things I found was quite interesting is that there are apparently over 16,000 forklifts in Walmart and Amazon warehouses in the US using hydrogen now. Because if you're using a warehouse, you don't want any emissions, because it's going to spoil your products that you're kind of moving around. So some of these just give an example of the rapidity with which some of these changes are happening, I'm suggesting. So the final slide, as it were. So how do we go for a world where we've got sort of less than 200 kilowatts of installed hydrogen fuel cell or fuel cells out there to being able to install 50 megawatt plus systems on our vessels? Infrastructure is probably the biggest challenge, and LNG also faces that as a challenge. But maybe we'll learn some of the lessons from the LNG process and actually be able to kind of piggyback on top of that with liquid hydrogen. The production process has got to somewhere that's got to really take off. I've got a sort of a slide, sort of capture from a Wärtsilä website where they're looking at this sort of floating distribution hubs for hydrogen. I think the real driver that will really make it cost effective is we start fuel cells and hydrogen start being rolled out, not maybe necessarily in cars, because they'll probably go with batteries, but larger vehicles. And if they start installing 100 kilowatts, 150 kilowatt type systems there, those costs will really get pushed down. That makes it a much more viable option. And it's nice technology. You can treat it like a battery. You can plug them all together. It makes redundancy built in, as it were, because you've got many systems. You could take one or two out and maintain them. It probably means it's easier to have autonomous power systems for your vessel because it's electrical power. You still got the challenge of the hydrogen, but that's going to be have to be a very controlled process. What would be really nice would be to find some higher density method of storing hydrogen. So I've got some colleagues in sort of chemistry in Southampton are looking at things like nanotubes, but this is probably a long time in the future, this technology. So just to sort of sum up, I think hydrogen is looking much more promising than it was 5 years ago. I think there's much more confidence that the technical challenges are actually solvable. If fuel cell technology, scales and costs reduce, then it becomes ever more viable. Likewise with hybrid storage, we're already seeing that. And if cities, port areas enforce really strict local emissions standards, that will force quite a lot of the operators to actually start converting their vessels, which we'll see is happening, and they'll become cleaner, and then some of the infrastructure effects will start to take hold. Will it be a world of fuel cells, or will it be a world of engines? I think there's one of the exciting things about this. I don't think anyone knows that answer at the moment. So I've just given you a little bit of a flavour about fuel cells, but I'm equally prepared the fact that we may go down a world where we still have a nice large engine. However, it's got a very different fuel to it. I thank you for your attention. I'd welcome any questions. Thank you.